Hello, everybody. Today we are going to talk about one of the looming issues for sustainability, data centers. Data centers are the backbone of our digital world, powering everything from social media to cloud computing. However, they come with significant and complex sustainability challenges. I didn't know that data centers are responsible for 1 to 2% of all CO2 emissions and up to 3 to 4 of global energy usage. I think these are huge figures. And as the demand of computing services grows, so does the environmental impact. In these episodes, we'll explore the critical issues of energy consumption, physical waste, e-waste, and water usage, and how current LCA and carbon reporting structures do not adequately fit for data centers. We'll discuss why these challenges are so pressing and how innovative solutions can help mitigate their impact. Roger will share his insights about on the looming problems of the industry, the importance of these specific issues, and the role of policy and regulation in driving sustainable practices. Stay tuned as we uncover the future of data centers sustainability and learn practical steps that stakeholders can take to minimize their risks and environmental impacts. Whether you are a tech enthusiast, an industry professional, or simply curious about the hidden cost of our digital age, this episode is packed with valuable information and thought-provoking discussions. My name is Elia, and we have today with us Roger Barkley.
Hi, I'm Roger. I work at KOSMOS. I've been in construction since the 80s, so I'm probably a bit older than I look. I deal mostly in specialist areas. So I've been involved in MEP and installations since the late 80s, early 90s. And since sustainability has come out, I kind of got pulled into that kind of through either my role in MEP, because a lot of it was to do with efficiency, or from the other side of things, because I do a lot of estimating at business case and concept stage and cost modeling. So yeah, that's kind of where I've come from historically. In terms of data centers, yes, I've been working on them since they were very sort of more like rooms within individual buildings, or like where banks used to have like a whole floor dedicated with their own dedicated servers, and it kind of drifted to their own off-site facilities, and then we start branching out into traditional data centers, hyperscale, and now we're off to the races with the next generation of data centers.
You've definitely gone through the entire evolution from its origin, and I also know that you are very aware of their future, especially with the sustainability mindset, which I also know that is one of your interests at the moment from a professional perspective. Could you, Roger, explain a little bit the types of problems surrounding energy demand for data centers?
On the energy side of thing, it kind of breaks down into a couple of points. First of all, there is the demand side problems, then there is the supply side problems. And you can talk about the technical side, and then you talk about the carbon impact side of that set of energy needs. So to start off with the demand side of things, that kind of splits into two parts. Again, there is the data centers that are built to date, and then now what we are planning to build. So we have a whole bunch of existing data centers. There's about 11,000 of them roughly worldwide. And if you go back to, as a good example, if you go back to say 2011, the average rack was consuming about 2.4 kilowatt hours, whilst 12 years later, sort of 2023, the average density has increased to about 8.4 kilowatt hours. So when we build a data center, I think a lot of people kind of think of it as this very static thing, or that the demand for that data center that's built next door to you, or that you just built as a consultant, that it's static, but it really isn't. We're talking about in a 10-year period, the average consumption or density, however you want to word it, increasing by a factor of 4 in about 12 years. And one of the looming problems is that's going to skyrocket again. Part of that is to do with the type of technology that we are using. So the most obvious one is AI. At the moment, the most common server that we use consumes about 6 kilowatts, but the more exotic ones go up to about 20 kilowatts.
And it's only
There's obviously less of them.
Increase, I suppose, right?
The AI ones clock in at about 60 kilowatts, going up to an expected 60 to like 100. Mm-hmm. So there's a massive jump without changing the number of racks in the existing data centers. We have already a power increase that is just doing this. And even though people will say, well, we've done certain things that improve the efficiency, what tends to happen is the factors that are pushing up the consumption are running at about 45% per year, whilst the efficiency gains that we are making through technology produce like a reduction of about 5. So we're making the demand is increasing at the moment at about 40%, though sometimes it's maybe as low as 20% per year that creeps up, which gets us to this times 4, times 5, times 10.
It is really far from being balanced. I hear easy math.
And it's happening at a time when we are everybody everywhere is trying to create the opposite effect with the decarbonization of the grid. On the supply side of things, as I was saying, we want our grids to get greener. But if you go back to like one of the things that kind of shocked you is we've got 11,000 data centers, but they are responsible for 1 to 2% of all carbon out of buildings. And they are responsible for 3 to 4% of all carbon from energy consumption, just 11,000 buildings. And we are talking about like power increases of times 4, times 5. So people get that part that power's going up, and they kind of get the point that we're trying to make our grids greener so they come down. So we're trying to make buildings, part of that is we're trying to make buildings more energy efficient. So imagine in a country that you're trying to make your grid greener and you're introducing more data centers, you're just throwing them in. That has an effect on the yearly average for how much carbon our grid has. Because let's say, for sake of argument, that we produce 500 gigawatts of green energy per year. If we throw enough data centers in, they will consume that chunk, and then we have to make up for it by burning fossil fuels. So maybe we start with biomass, we run out of biomass, we run to the next cleanest one, which is natural gas, and then we run to coal. So when you have huge demands stepping up what we need from the grid, it forces us it consumes all the green power that we've got, and we start having to make up with dirtier ones. So politically, it's not great for the politicians who want to see that number going down every year when you're creating a pressure that wants to push it up.
They're applying policies to try and reduce that, while at the same time we are increasing the demand in the grid, meaning that, yes, we may have a lot of green energy, but it's not going to be sufficient if we look at this exponential growth of demand and consumption that you are mentioning for this specific building type or sector of the industry.
And it's part of it is just the dynamics of the power demand. It's not like we're creeping 2 or 4% per year. We're talking about 4 to 5 or 5 to 10 times in the span of 10 years. So when you look at, say, a government's plan for expanding green energy, you don't normally, when they're starting off very early on, it might look like we're doubling, tripling. But once you've established large quantities of green energy, you're no longer doubling every 10 years. You're increasing by percentages, like 40%, 20%. They're kind of running counter to each other a little bit if you just leave it down to the government's plans for how much green energy it's putting into the grid.
It seems like a variable with a huge impact. The policies or the idea of reducing or increasing the green energy in the grid based on the illusion that the consumption will be the same or even lower, right? With all the policies of trying to reduce energy consumption, etc., for all the industries at home, safe in all levels. So it could be expected that the consumption of energy will be the same or less. But actually, what we know for a fact is that it's not going to be the case, and the consumption is going to increase exponentially, at least for this specific building type or building operation type. And therefore, the policies for increasing the green energy in the grid are short. They are not accounting for this massive consumption.
They have to account for the energy creep in the existing data centers that you have. And then you also have to factor in so even though these new ones will be configured to allow for AI servers, because actually the traditional ones in theory are restricted. The infrastructure that they've built into the building has an upper limit. So although they've designed them to be able to take a certain increase, say, in temperature loading, when you introduce AI, you can no longer use the more old-fashioned cooling systems like the airborne ones with crack units for the whole room or hot and cold aisle. The AI servers, because they use so much energy, produce 3 to 5 times more heat. So it's no longer possible to use, in some cases, the traditional data centers will max out. They might be able to get 15 to 25% replacement of traditional servers with AI servers before the cooling system just can't handle it.
Before hitting the capacity they've been originally designed for.
Yeah, or even it could even be the electrical cabling was not designed with the increased load in mind, or the bandwidth of the data cables coming in. There's a number of things that might restrict the traditional data center and force the traditional data center, if they want more of these, more AI that's more energy dense, they're going to have to retrofit, or they're just going to have to stop at a certain configuration.
We are discussing here demand, energy, and consumption from the data centers. I'm curious here, are they passively consuming, or it is also a matter of concern, the waste, physical waste, as well as the electronical waste, e-waste, that they may produce?
Yes, this is one of the things that's kind of under the hood of the car that you can't see, that a lot of people aren't thinking about. And it is not covered by LCAs and other scopes that we'll talk about later. But the thing that people are missing is, in terms of physical waste, I'm a little dubious about the figure that's thrown around, but it's claimed that there are 200 to 250 million tons of physical IT waste produced per year. Whether that comes entirely from data centers, I'm a bit dubious, but one of the things that is clearer is the servers in the racks in the data center, they have a lifespan. They are replaced on average every 3 years. And it's not because they've broken. It's not because they are technically obsolete. It's more to do with competitive advantage, or it's more to do with servicing more customers. So if you imagine I spend 500 million on a data center and I've got 2,000 data racks in there and I can serve 1 million customers. If I can every 3 years replace one of those servers with something that allows me to now service 1.2 million customers, that's obviously better for my business. And if my processes are running faster, then I can maybe charge a better rate, or I've got a competitive advantage versus other data centers. So a big part of this physical waste problem that people aren't seeing is just the replacement rate of equipment, that it's not what we think of in the traditional construction industry sense. We tend to like think of an effective lifespan of a building part, like is a door or window operable, is a chiller unit, at what point does its maintenance costs start to reach a point that we say, let's just replace it? They are thinking in very different terms. And on the kind of ecological problem side of things, the next step is like when we think of Section D and we think about circular economy, that our ideal world is that we expand the lifespan of something so we don't need to replace it. Following that, we want to reuse it so there's only a little bit of carbon to swap it and let somebody else use it. Then the next step down is to repurpose it, so make some adjustments, a little more carbon to add or subtract before we reuse it. And then the kind of bottom of the run is to break it down into raw materials to reuse instead of mining new materials. And then we get into the worst part, which is disposal. Can we burn any of it to get some kind of energy from it, or is it just dumped waste? Mm-hmm. And with the server replacement, we're in a situation where there doesn't seem to be a secondary market. So we're not reusing, we're not repurposing, we're not expanding its lifespan. So all the best circular economy solutions are bypassed currently, and we go straight to recycling or throwing it in the tip. And with the recycling, part of the problem is some of the materials in the servers have a very high recyclability factor, 75% to 99%. But some of them are very, very low, like 1% to 10%. So there is, again, that side of things with the physical waste where there is a set of problems that need to be looked at because they are swapping the servers out so quickly. And in terms of the circular economy, they are defaulting to the worst side of the scale, which is either throw it or just recycle it. And then if we recycle it, we're only capable of recycling a proportion of it. On the physical waste side of things, the thing that catches people out by surprise is the server replacement. That is the very fast kind of replacement rate. There is an intermediate kind of replacement rate, which is 5 to 10 years, which tends to be more to do with redundancy.
Yes.
Because the data centers are referred to normally by tiering systems, tier 1, 2, 3, and 4, which is to do with how accessible your data is. How many hours per year would your servers potentially be down? So data centers are built with an awful lot of redundancy in, and they want to maintain that tier rating and avoid downtime. So there is, on top of this very fast recycling rate, the servers every 3 years or 1 to 5 years sort of range, there are some equipment like batteries, or maybe there are other parts that relate to that redundancy, where they want to ensure that the redundancy is always there, so they will replace those building elements every sort of 5 to 10 years. So it's not always just the IT equipment. Sometimes it drifts into the actual what we would think more as construction people as our stuff, maybe. There is an interface point between the two where, because of redundancy, they might replace it every 5 to 10 years, 10 to 15, just in much shorter lifespans than you would normally be used to for most other building types.
That will be the installations or the equipment.
Physical installations
to supply operation
might last longer. That if you would say that maybe traditionally you might on some things go 25 years for some MEP installations, some of them are reined back to 20 or 15. So it's still shorter, but it's not the super short 3 years, 5 years, 10 years. The 5-10 years is normally the interface points between the IT equipment and the physical building components.
And Roger, this will be all physical waste, and I'm very curious about the e-waste, to which I'm an active contributor because I don't delete any of the copies and backups. So I presume that's part of the drop in the ocean that makes the e-waste go to those figures you mentioned.
Yeah, this is another one that surprises people that's not on their radar as businesses or as individuals. It's estimated that about 43% of all data that we store is single use. So as a business, it's like that memo or it's that email that came in and you just stored it somewhere. If in your private usage, it's that
the blurry
the message you sent, it's the GIF, it's the TikTok video that lasts 20, 30 seconds. And part of the problem is that the methods of communication tend to become more dense. So you've gone from text to picture to video. Also, there is this expansion of the ways that we use data is expanding. So if you looked at, say, social media as an individual, the scope of people using it has increased by about 10% in the EU in a 10-year period. So it's just kind of ballooning. And then this single-use data is ballooning, and it goes somewhere on a server, and the energy consumption isn't zero. So, for example, an idling server compared to a active server runs at about 40% of the energy use. So, if the average server is like 8.4, maybe say active is lower at about 6. 40% of that is like the equivalent of an idling server that's just sat there with essentially e-waste on it. So people don't realize they're not just have a history of e-waste that they're building on. They are expanding the types of data that they are putting out there as single use, and they are becoming more data intense.
And the more into data we are, obviously, the more data we produce and consume. And it's memory, right? It's the space necessary in the servers to store all these data, and from time to time create backups of it, and also to basically just have it up in the cloud for whenever you want to access. That's all energy running for things that I'm aware of it, but I don't actively delete all the stuff that I know I'm never gonna look at. It's
that human behavior to hold on to something. But the other point is that AI also, in its learning process, produces a lot of data.
So the installations and services, which is the part that obviously we are more familiar as from the construction industry, besides equipment, and these cooling systems, etc. Is that what you meant by water consumption, Roger, or is it's related to something else? I actually don't know. Why is water going to be a problem for data centers? In which sense?
It's to do with what we've been traditionally using as the default way to cool the servers, because 2/3 of all of the energy demand tends to be in the servers, but 1/3 is in the cooling. And the kind of default way we've been doing it up till now has been sort of air handling units on a chilled water circuit that has a secondary circuit that goes to a cooling tower. And because the heat is so consistent, the quickest way to kind of reduce it is to have like that open loop system where the water comes down, the wind can get at it, but you lose a certain amount. And globally, it's something like 1.8 liters of water for, is it a kilowatt? I think it is, of 8 kilowatts of power that they're using. So it's quite a lot of, when you use that traditional cooling system, there is a lot of water usage, and it's kind of overlooked. because there's only, as I say, there's only 11,000 of these sort of buildings in the world. And when we look at LCA and these other things, there's a section for water called B7. But historically, people ignore B7 because most building types don't have a very high water consumption. But there is carbon involved. We use about depending on what country you're in, about 0.34 to 4.3 kilograms of carbon to process and distribute a cubic meter of water. So not just data centers, but any large sort of industrial enterprise that uses a lot of water is de facto using quite a bit of carbon.
In that specific category of the ranking, yeah. And is a matter of consumption of water, or it will also be considered the pollution of water? Because you are mentioning the water gets evaporated, but if they return that water in any form to the grid again, right? That water will be at a certain temperature. Is that also pollution of water? It's considered as pollution of water?
It's two loops within the heating system, so it's more to do with just the general consumption. But the consumption, to take Spain, for example, it's not a theoretical problem, it's a present day problem. So if you go to Spain has, you probably know this, a problem where farmland is becoming desert slowly because the global changes in weather that have already happened mean that there's insufficient rainfall to refill the aquifers underground. So businesses like intensive farming or data centers that draw water, say, from aquifers, essentially through the water grid, they're impacting the ecology of Spain like present day now, not 5 years, not 10 years now. It's actually visibly observable.
Or golf camps, or a type of agriculture that is not natural from our country, like avocados or the like, right? The type of high demand agricultural products that are not meant to be grown there.
Yeah. So in some countries, they would feel this bite far more intensely and be aware of it than other countries where there's water scarcity isn't a problem yet.
Right now, most of the calculations for LCA are based on, of course, the first categories, which are the ones that everybody has focused on. When it starts to move into the next categories, does LCA fit this type of buildings, or we will have an issue in regards to data centers and how LCA reporting has been developed to fit the general building type, but maybe not specifically these ones?
Yes, there is. As you start to look at certain types of building, you can see that the current steps in the evolution of LCA do not adequately fit what you could call production-based buildings. What you kind of start to notice happening is that buildings separate into two types. There are people buildings, which are like schools, offices, apartments, and then there are production-based buildings. So data centers, big pharma, manufacturing, and especially ones that do continuous operation. So they're running 24 hours a day, like with a data center, or with manufacturing, where they maybe work 3 to 4 shifts of different staff, but they're still running 24 hours a day.
Yeah, non-stop, yeah.
Yeah, because at the moment, when we have constructed our benchmarks that we want to construct to for carbon, we've been very focused on people buildings. So we've got whole life carbon as a template, but what we do is we have been, in each country or organization, we've cherry-picked which ones we want to look at and which ones we don't. And most countries, for example, ignore B7, which is water, or the carbon associated with water consumption. So you can see straight away that does not fit production buildings, because production building, even though they're only using it for, in this case, for cooling, in other manufacturing ones, you also have a cooling demand, but you may also have a water demand for the actual production of whatever it is that you are building. Mm-hmm. So obviously you can see there's an issue there that for production-based buildings, maybe B7 should be in there. Another problem is that because LCAs have been built focused on people buildings, we have assumed that the average lifespan of a building in most countries is taken as 50 years. A few countries use 60. Data centers and some types of manufacture, that is just not even close to what the average lifespan of those buildings will be. It may be as short as 30, 25 years. It could be literally half. So again, the traditional way of looking at LCA doesn't fit for those types of buildings. And you can see why they'd overlook them, because with the data centers, there's maybe only 11,000 of them globally, but their impact is potentially huge because, again, 3 to 4% of all carbon from energy uses is coming from just 11,000 buildings.
And that's definitely going to affect the community grid in regards to consumption to it. It's going to affect to the municipality plans. So it's going to break them all if they also start increasing the consumption, as you said at the beginning. Yeah. It is a matter that it is like we of course got started with the building as a physical asset itself as first steps, but maybe what we are not realizing is that when we start looking into the next stages of LCA B7, it's not so easy to retrofit without actually producing waste again, right? To replace all the equipments to make them more optimal for energy consumption. And it's actually something that needs to be looked at project stage, design stage, and not something that we could fix later just because it's further steps on the phases, right? It's not something that we can address later on. Oh, let's get started with A1, A6, and then we'll look at B7 later on when we have time, when the building's running. That will be late because it's something that you need to take into account while you're designing these buildings, isn't it?
If we're evolving how we do LCA, like in Denmark, we started with one target for all buildings. Then we realized we should split it by different building types. Mm-hmm. And we realized that in the future, we need to split out refurbishment from new build and give them targets. It seems to be becoming clearer that we also need to split LCA in half between people buildings and production-based buildings. And we also need to look at what goes into B6 is the energy one, because at the moment, what we're doing is we're ignoring about 2/3 of the carbon from electric. Because what we're saying is, because we're thinking of people buildings, we're saying this stuff to do with production, let's keep that out of the LCA calculation. We only care about the people side, but we're not even doing that cleanly. So for example, with a data center, we might ignore we would not build into B6 the consumption of the electricity for the servers, but the heating that is directly linked to the cooling, which is directly linked to it, could very well be in the B6 calculation. So there is an inconsistency in the logic of how we are even calculating the B6 carbon effect for electrical consumption now. I think that it needs to be put in, because if you push it out, that means the only place it is currently captured is in ESG metrics or in your taxonomy reporting. But the difference between LCA and the reporting structures is reporting, all you're doing is saying what I'm doing right now and what I plan to do in the future. With LCA, it's active. You have to look at it now. You have to do something about it now to get to this limit that we are setting. It's like you lose the control, and we need the control because year after year we're failing to hit our carbon reduction targets. So even here in Denmark, where we were supposed to be going down to say an average of 10.5 next year, now it's going to be 8 because, and part of that's to do with the industry. We have an enhanced target, and the market said a certain percentage said, yeah, we'll go for the enhanced target. We have seen as a company that people will ask for it, but realize it's more expensive than they thought, so they don't do it. And if you go to something like an engineer's database like Swaco, you can see they had 350 odd projects on there. And I think there was only one that actually went for the enhanced lower level of carbon.
All right.
And just to put that into context, if you wanted to be Paris aligned, you'd actually have to be down at 2.5.
So it's not even
the drift just makes the curve to get down to where we want to be steeper and steeper each time. So we should be taking the whole thing in. We should say, yes, production, people buildings, production buildings, B6 should be everything. Maybe we start off at a very reasonable target like we did for buildings in general and then tighten up on it. But it's not a good idea to just push it away and say, well, that's to do with your business. Put that into your ESG and taxonomy reporting forms.
So at some point, they will need to monitor their consumption and to be able to report it. That's also part of it, isn't it? They will need to monitor the operation.
Do that within their corporate and financial disclosures under taxonomy, and there's certain requirements for that as well under ESG, depending on what reporting structure you do. But it is more about reporting. It's not a fix right now. It's this is where I am now. This is what I'm planning to do vaguely in the future. So there's far less control at a time when we need the control.
All right. So that will be a way to improve the LCA standards, breaking it down by building types. So this way we could specifically address the sustainability challenges of these building types. Interesting. And therefore, from how could we achieve that? How could we achieve that? It's politically, or is who could really get to affect or to make a change in the LCA standards to cover for this?
When we talk about who can do what, you're down to the stakeholders. So you're down to politically, what can politicians maybe do? Or when you talk about politics, there's the politicians and then there's the people, because sometimes when a topic becomes a hot button, that creates pressure on the politicians to maybe do something and pass a legislation. Then there's obviously the what can we do as consultants and the like within the industry? And there is the main one, which is the clients. On the client side, there is two parts to this. One is a certain proportion of the data center owners are brand affected. So if you think Google, you think Amazon, you think Facebook, now Meta or whoever, there is reputational damage if they wait too long on certain things. And there is a benefit to them being pragmatic. So for them, the solution is to be aware of all the problems and not wait for the finger to point at them. It's more a case of them spotting all the problems and doing something about it that is cost effective. So when the finger starts to get pointed, it's not, oh yes, we see there's a problem, here's our plan. It's, yes, we've already realized the problem and we've already done something about it without being forced. And these are the next steps that we're going to take. Because obviously there's cost-effective solutions and less cost-effective solutions. So they should really be pragmatic and start looking for the cost-effective ones, just to give themselves that protection to their brand. The same also applies to people who aren't brands but who are businesses. Because obviously if they wait too long and other people are updating, doing things about these problems, they maybe suffer in the marketplace because it's harder for them to maybe sell their server space to businesses that are interested, because those businesses may be under the scrutiny of green measures. So from both sides of the client's perspective, there should be a desire to do something cost effective about all these little things that could become a big finger pointing at them. From the consultant side, again, it's the awareness and developing some ideas about cheap solutions. So if the client isn't aware that they can say to them, by the way, are you aware of this? And here are I'm pointing out a problem, but I'm also providing cheap solutions as a starting point. And later on, if it grows to a bigger problem, we can talk about the bigger issues.
Mm-hmm. It definitely will be cheaper for them to plan for it ahead rather than retrofitting later on.
Because a big part of this that catches people out cold in the construction industry is dynamics. The construction industry is historically a very slow-moving thing. If you look at building regulations, we update them every 8 to 12 years. We are building with materials like brick still that we were using hundreds of years ago. We're still using similar practices, similar machinery. The IT space and the carbon space are, however, dynamic. So as I mentioned with the servers, the types of things servers can do, the power demand goes up at a very sharp curve. And the carbon reduction is a very sharp curve. We have to reduce carbon every 2 years. And that's a problem because the industry is not used to this dynamic way of moving every 2 years. It has difficulty moving at that speed, and so does the marketplace for solutions. Because if I see, okay, carbon has come down for a certain type of building from 10 to 8%. That was easy because we found cheap solutions. Now it's from 8 to 6. Now I've got to use more expensive ones. And if I realize as a business I need to produce products to serve that, I can't bring it to market quick enough in a 2-year period. To extend my factory to increase my output will take more than 2 years. If I create a new technology but it's expensive, normally the first product, it normally takes 5 to 10 years to half the unit price. So the entire industry has to accept that this is a dynamic situation, so it has to think proactively and dynamically.
All right. I think we get there, or you want a further question, as in, for example, and as per this, what practical steps can stakeholders take to minimize the future environmental impact of the data centers?
I think I already answered that one.
Then we closed it.
I don't think it's worth muddying the waters with the geopolitical one.
We have closed it. Maybe as the closer, we could briefly touch on what innovative solutions are being implemented to reduce energy consumption and CO2 emissions in data centers, or not worth to go for that. So, Roger, very interesting. We can see that the data centers are going to impact greatly. They are already impacting greatly our energy grids. They are only going to do so into a more harmful in the way, or more strongly way, just because of the technology we use, and the slow development of innovative solutions to mitigate this. Technology is not fast enough. Construction is not fast enough in order to balance the scales for these specific building types. At the moment, I can see that the LCA standards are not suiting, or are not meant to address specifically the issues of specific industries, data centers. But I'm pretty sure there are many others that are also slipping through till there is a point when these standards developed and evolve and actually address this, which will be late for this industry to actually take action and try to go back and retrofit, especially when the main way to address these challenges will be the physical asset, as well, of course, as some other technologies, but in this case will be the physical asset, the consumption, the efficiency of their operation, to reduce their impact in the grid, and for sure the stakeholders have the power right now to plan ahead of this and involve the right stakeholders in their projects to look at it, to provide them with advice, proactive advice, to get ahead of the curve. not the consumption curve that goes up or the LCA curve that goes down into more demanding requirements, but actually ahead of the curve of getting to bring down and balance down the exponential consumption curve, the dropping limit of CO2 carbon curve that goes on, and try to bring those together to get their projects into a right setting for fulfilling sustainable requirements. Well, thank you very much, Roger. Very insightful. If someone is curious about this, you can reach out to Roger. He knows about this. He could be talking about hours about the data center sustainability for this building type, but for many others, I know that. So thank you very much, Roger, for your time and bringing so insightful details of this hidden looming problem at the moment.
No problem.
Thanks very much for listening. There's a LinkedIn link below in the show notes. We would love to connect with you.
We hope you enjoyed it and have you with us in the next one. Thank you very much.